Question 12, Part C. Kim and Alex start jobs at the beginning of the same year. Kim's annual salary in the first year is $30,000 and increases by 5% at the beginning of each subsequent year. Alex's annual salary in the first year is $33,000 and increases by $1,500 at the beginning of each subsequent year. Part 1. Show that in the 10th year, Kim's annual salary is higher than Alex's annual salary. Kim's salary increases by 5% a year, and it's an example of repeated percentage increase, and it works in a similar way to compound interest. Now, in the first year, Kim's salary is $30,000. So her first increase starts in the second year, and her last increase is in the 10th year. So there are 9 increases of 5% each year based on the previous year. So we can model this using a geometric progression. So Kim's salary in the 10th year is given by $30,000 multiplied by 1.05. This represents our 5% percentage increase, and we raise that to the power of 9 because there are 9 percentage increases over that 10-year period. And that gives us $46,539.85. Now, in contrast, Alex's salary increases by the same amount each year of $1,500. So it works like simple interest. And there are 9 increases of $1,500, and it's the same increase each year. So Alex's salary in the 10th year is given by $33,000 plus 9 times $1,500, which gives us $46,500, which is less than Kim's salary in the 10th year. Therefore, Kim's salary is higher than Alex's salary in the 10th year. Part 2. In the first 10 years, how much in total does Kim earn? Using the geometric sum formula, Sn, so that's the sum of the first n terms of the geometric series, is equal to a times 1 minus r to the power of n in brackets divided by 1 minus r in brackets, where a represents the first term of the series, in this case $30,000, r represents the common ratio, in this case it's 1.05, and n represents the number of years. So in this case, we want to find out how much Kim earns in the first 10 years. So n is equal to 10. So substituting these values for the variables in the formula, we get S10 is equal to 30,000 times 1 minus 1.05 to the power of 10 in brackets divided by 1 minus 1.05 in brackets. And that equals 377,336.7761. So rounding that to 2 decimal places, Kim earns $377,336.78 in the first 10 years. Part 3. Every year, Alex saves 1/3 of her annual salary. How many years does it take her to save $87,500? We can model this situation 1 year at a time as an arithmetic progression. Let AN equal the amount saved in the nth year. Now recall that Alex receives an increase of $1,500 in the second year and then every subsequent year from there. So the amount that Alex saves in the first year, so A1, is equal to $33,000. Divide that by 3 and we get $11,000 saved. The amount that Alex saves in the second year, A2, is equal to $33,000 plus $1,500 in brackets, divided by 3, and that equals $11,500. The amount Alex saves in the third year, A3, is equal to $33,000 plus 2 times $1,500, since she receives 2 increases by the third year. Put that in brackets, add those two together, divide that by 3, and we get $12,000. And the pattern continues in the same way. So we can see that each subsequent year, the amount saved increases by $500. So this is an arithmetic series where the first term A is equal to 11,000, the common difference D is equal to 500, the sum to n terms is $87,500. What we want to find is the value of n That gives us $87,500, and the value of n represents the number of years it takes Alex to save $87,500. So using the arithmetic series sum formula and substituting 11,000 for A, 500 for D, and 87,500 for Sn, we get 87,500 is equal to n over 2 times, now open bracket, 2 times 11,000 plus 500 times n minus 1 in brackets, and then close brackets there as well. Now we can eliminate this denominator of 2 here by multiplying the left-hand side by 2. So we get 175,000 is equal to n times 21,500 plus 500n. Now we get that by multiplying the 2 and the 11,000 together. So that gives us 22,000, and we subtract 500. Since we expand the brackets here, we get minus 500, and that's where the 21,500 comes from here. And we multiply the 500 and the n together here, and that's where the 500n comes from here. Expanding the brackets on the right-hand side again, we get 175,000 is equal to 21,500n plus 500n squared. We've formed a non-monic quadratic equation. Now we can divide all terms by 500 to convert it into a monic quadratic equation, which is generally easier to solve. We get 350 is equal to 43n plus n squared. Rearranging this equation, so it forms a monic quadratic equation with 0 on the right-hand side, we get n squared plus 43n minus 350 equals 0. Now we can factorize the left-hand side. We get n plus 50 in brackets times n minus 7 in brackets is equal to 0. So n is equal to negative 50 or 7, but n represents years and it has to be positive, so n has to be greater than 0. Therefore, Alex needs 7 years to save $87,500.